All right, let's take a look at part 2 from chapter 2. I think pretty straightforward. When I look at this first function, all we're supposed to do is draw a complete graph, so we could just t-chart. But I would like to think that we know that the absolute value of x, that function, just plain old absolute value of x, looks like this. We get that from t-chart. Again, I'm just working with the absolute value of x. Put in 0, get out 0, put in 1, get out 1, put in 2, get out 2, put in -1, get out 1, put in these are 45s here. These are slope 1, slope -1. So if we know what the base function looks like, I would hope that we could graph this one instantly. This is what I would refer to this plus 3. I'm adding 3 before I go into the base function. And if I have a function, I'm going to consider the x-axis to be time and the y-axis to be height. I put in time and I get out height. That's pretty normal for all the functions we graph. We put in time along the x-axis and we get out height. Well, here I'm choosing my time and I'm adding 3 to it. I'm not affecting the height here. I'm affecting the right-left. And the common mistake would be to say, oh, well, it's plus 3, we must move to the right. No, to get credit for 0 time, I put in -3. To get credit for 0, I put in a -3. This is like a 3-day head start. So what normally happens on day 5 now would happen for putting in 2, day 2. That's 3 to the left. You might want to think of that in terms of MyVox. So this graph looks just like this, except we'd say it's 3 to the left. So I can just go 3 to the left, 1, 2, 3, and then build my 45s. Up 1 over 1, up 1 over 1, up 1 over 1. Up 1 over 1, up 1 over 1. And we could get that from t-charting as well if we had to. But if I don't have to t-chart, I'm not going to t-chart. Okay. Now, other things we might talk about on this, they didn't ask for it here, we might talk about domain. Domain, we scan from left to right. This graph's going to start at -infinity and continue until infinity. Range, this graph's going to not start until we get to 0, and it's going to continue until we get to infinity. How about 0? Parenthesis or bracket? Bracket. We're going to include 0. How about infinity? Parenthesis or bracket? Parenthesis, because it's in effect saying, yeah, we know we can't ever get there. Okay, so that would be the range. Does the graph have symmetry? Yeah, it has symmetry, but not over the y-axis. It's not an even function because it folds onto itself, right? Has to fold over the y-axis onto itself. So it's not an even function. Okay, B. I haven't specialized in this graph long enough. I think I would t-chart this if I had to. I would expect probably fairly simple graph, but going to be interesting around what value? When are absolute values interesting? When inside of them shifts from positive to negative. So I would definitely build this thing around 0. I can't put 0 in, though, because of the denominator. So we might say, well, 0's an asymptote. Maybe. You could come over and say x equals 0 is certainly like an electric fence, can't touch it. We'll see if it acts like an asymptote or not. So I guess I'd build around that. Let's go to 1. Put in 1, get out 1 over 1. Put in 2. This just becomes 2 over 2. Put in 3. Doesn't take too long to figure. I put in anything to the right of 0, I get 1. Put in 1, get out 1. Put in, this is 1. Sorry. Put in 2, get out 1. Put in 3, get out 1. So everything over here I believe is 1. And I'm coming into this now. Is it acting like an asymptote here? Like it's going to suck it into it? No, we're just slamming into that thing. Hole in the graph. Not an asymptote. Okay? But we can't touch it. So the mistake here would be to think, oh, okay, well, automatically, I guess that means it just hangs out up here. We better test. X, Y, let's go to -1. Put in -1, and I get positive 1 on negative 1. Put in negative 2, and I get positive 2 on negative 2. Put in negative 3, I get positive 3 on negative 3. So I believe we look like this, and we just slam in again. Can't fit there. So if we were talking about some of our other topics here, domain. We could say domain x cannot be 0. I don't know how the book's handling this, but those of you who are looking at answers are seeing we're dealing in interval notation all the time. Does the book list it like this ever? The book might list this as negative infinity up to 0 not including, or 0 up to infinity not including. Seems like a lot of work to do it that way. Range, a little bit more interesting. As I scan from bottom to top, this thing only exists at negative 1 and at 1. Range would be f of x or y equals 1 and negative 1. And the question would be, what if we had to put that in interval? Boy, I don't think you're going to have to, but it's ugly. We'd say, well, it starts existing at negative 1 and continues to exist only to negative 1. Or it starts at 1 and stops at 1. Kind of peculiar. How about symmetry? Does this have any of the types of symmetry we talked about? Is this an even function? No, it doesn't fold onto itself. Is it an odd function? Odd function is rotational. If I spin this 180, does it lie on itself? Yeah. When we talked about odd functions, it said if f of negative x equals negative f of x, it's odd. What a horrible way to read that. If the height to the left is the same as, or is the opposite, opposite of the height to the right. Well, yeah, my height to the left is the opposite of my height to the right. But we can see it's symmetric. Okay, C, wouldn't be a bad time to pause recording and give this a try, but we're just going to go right into it. I'm going to choose values for x and y because I don't specialize in this function. If it's x plus 3 squared, then yeah, I don't need this, but probably ought to deal with this. I certainly want to build around 0 because of the absolute value here. If this was x minus 7, I'd build around 7. But I want to build around zeros. I can put 0 in this time. I get 0 minus 0 onto 0. I'm going to go to 1. 1. I get 1 minus, no effect, absolute value. 1 minus 1, 0 onto 0. I go to 2. 2 minus 2, 0 onto 0 onto 0. So I believe this looks like that. The mistake would be to not respect the absolute value and think maybe it's doing something different when we put a negative value in. Maybe it's the same. So let's go to negative 1. I get negative 1 minus, the negative 1 comes out here as a positive, I get negative 2 on 2, negative 1. Is that all right? Let's put in negative 2. Put in negative 2. I get negative 2 minus positive 2, all on 2. I get negative 4 on 2. I get negative 2. One more to convince me. Negative 3. I get negative 3 minus positive 3, negative 6 on 2, negative 3. I'm pretty convinced. You might want to go back and put in negative 0.1. Okay. Let's take a look at this thing just for a second. If x is, I'm going to try to write this as a piecewise. Watch this. If x is greater than or equal to 0, isn't it clear the absolute value doesn't matter? If x is greater than or equal to 0, the absolute value doesn't matter, and I get x minus x on 2. I get 0 on 2 or 0. Right? If x is less than 0, though, if x is a negative number, follow this, x comes out as the opposite of x. Right? If x is a negative number, x comes out as the opposite of x, and I get x minus the opposite of x on 2, which is 2x on 2, which is just x. Look at my line. Isn't that the line x? Okay? So if we treat it like a piecewise, oh yeah, that makes sense. Okay. Speaking of piecewise functions, a couple ways we could do this. We could t-chart. Now, careful here. What do you think I believe is the most interesting value of x in this whole piecewise function? I would see why people would think 3. It's not 3. It might be 3 if this was absolute value of, or if this was squared, but this is going to look like a line, right, with y-intercept 3 and slope -1, but it's going to stop at x equals 1. I want to build around 1 here. This is just going to be a line. In fact, I could do this. If I treat this like -x plus 3, I know what that line looks like. Forget about the restrictions. That's up 3 with a slope. I'm doing dotted line, so don't draw it in solid. It wants to look like that line. And then my second function wants to look like y equals 2x. That's here and here and here, up 2 over 1. Wants to look like, again, that's just dotted lines. I'm not trying to fill it in. Wants to look like that. But my red line only exists to the left until I get to 1, from -infinity to 1. So this red line does exist here, exists here, exists here. Now, careful, it doesn't exist down to 1. It exists when x gets to 1, and x gets to 1 right there. Now, for the purposes of just this part right here, should this be a solid dot at 1 or a circle? Solid dot. Okay. So now I'm ready to track the blue line. I would probably write this as x is greater than 1. So when x is greater than 1, I get 2x. So when x would be 1, I'd be looking to put a circle on 2 times 1, 2. But the circle's already covered. So I'm just going to start from here, and then I have slope 2. Now, you could t-chart this if you wanted. I want to point one thing out here. Let's say this was x minus 7 instead of 2x. If it was, you don't need to write this down. When I put 1 in here, I'd get -6. So I'd have my red line, then I'd jump down to here, and I would have a circle there. Right? Is that clear? So we'd come down to a dot here, circle there, and then we would continue up that way. It's just, we've had kind of a pattern of our piecewise functions always meeting at the same point. If they don't meet at it, we can't have a dot here and have it even be a function. Wouldn't pass the vertical line test. So we either would have 2 holes or we would have a hole and a dot. Okay? All right. So most interesting value on E is 5. I'm going to build around 5. I don't even know if I need to t-chart this. If I put 5 in, it gets treated here because x is greater than or equal to 5, and it turns it into 0. So at 5, 1, 2, 3, 4, 5, we are 0. At 6, we are 0. At 7, we're 0. At 8, we're 0. We're 0 beyond there. For this one, I'm going to put 5 in here first too, but I'm hunting for it with a circle, right? So I go to 5, treat it here, because I could put 4.999999999 in there, treat it here, go to 5, it wants to be a 1, but it circle. And everything to the left of there is a 1. Is that okay? And now, let's say we didn't see this. I don't even need that to solve these. F of 0, the height that 0 is 1. F of 5, the height that 5 is 0. And F of 6, the height that 6 is 0. Simple, right? Okay. All right, a little bit more going on here, but I'm going to treat the beginning of this one. I'm going to treat the beginning of this one like we understand what the graph of negative x squared plus 4 looks like. I could t-chart it, but this ought to be in our wheelhouse. This looks just like x squared. Well, what does x squared look like? We know what that looks like. Looks like this, vertex 0, 0. We would go over 1 up 1, over 2 up, over 2 from the vertex up 4, over 3 up 9, over 10 up 100. This looks just like x squared, except it's upside down and up 4. That's post function. It's up 4 and upside down. So I'm going to go up 4, 1, 2, 3, 4. Upside down, over 1, down 1. From the vertex, over 2, down 4. From the vertex, over 2, over 3, down 5. I would go right 1, down 1, and I would keep doing that until I got to 1. Not quite 1. Therefore, that one should be circled. Is that all right? You could do this with a t-chart. But I look like this parabola right here. Any questions there? Okay. Then for my second function, I could, and I'd probably be tempted to do it if I didn't have a fraction right here, I could start at 3 halves right in here, and I could go up 3 over 2 and like kind of sketch in the line. Or I could just say, well, let's just throw 1 into here. I'm throwing 1 in here looking to put a dot because of the equal to. I put in 1, I get 3 halves plus 3 halves, 6 halves, 3. So 1, there we go, fill in the dot. Doesn't have to be there. Could have been down here with a different function. Might as well jump to 3. I could jump to 3, or I could say, well, from that point, it's a line with slope 3 halves, up 1, 2, 3 over 2, and that over 2 actually gets me to 3. And that's a dot. Okay. And the last one, I could start at the line x plus 3, 1, 2, 3, and I could go up 1 over 1, 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 up 1 over 1. Or I could just say, let's just start at 3 and look to put a circle on the graph. I put 3 here, I get 3 plus 3, 6, so 3, 1, 2, 3, 4. Sure enough, it's right on there, so that just stays a dot. And from there, up 1 over 1 has a slope of 1, so a tiny turn. Is it clear? Let's say this was x minus 2 instead of x plus 3. Don't write this part down. If I put 3 in here, I get 1. So 1, 2, 3, 1, that would be a circle here. And we just jump from there down to here. Is that all right? So compute f of 0.5. F of 0.5. You could change that to 1/2 if you like. But 0.5 is less than 1, so we're treated as 4 minus 0.5 squared. That's 4 minus half of a half, 4 minus a quarter, 3 1/4. 3 3/4, I'm sorry. 3.75 or 3 3/4. F of 1 gets treated by the second function in our piecewise. So that's 3 halves times 1 plus 3 halves, but it's on our graph already. That's 6 halves or 3. F of 3. 1, 2, 3. F of 3 is up here at 6. You could grab it from the graph if it's convenient. And F of 4, well, let's see. 4, maybe not. Well, it does look convenient. F of 4 looks convenient. We could probably pull it off the graph, or we could say 4 gets treated down here, as x plus 3, 4 plus 3, 7. Okay. All right. Now, I know each one of these wants to look like a V. Make this your best couple of minutes in here. Let's say x is bigger than 5. If x is bigger than 5, this absolute doesn't matter, this absolute value doesn't matter, this absolute value doesn't matter, and this would just be what? 3x minus 4? It's going to be linear, 3x minus 4 eventually. You with me? And if, let's say, x is less than 0. If x is less than 0, then this is the opposite of x, right? And this is the opposite of parentheses x minus 1. And this is the opposite of parentheses x minus 3. But I'm just combining x's. It's going to be linear. All right, let's say, stay with me. Let's say x was 2. This would just be plain old x, 2, right? This would be plain old x minus 1. But this would be the opposite of. So I'd get an x, I'd get an x, I'd lose an x. What I'm saying is, no matter where we go, it's linear. But I expect weird things to happen. Where? What values, absolutely no doubt about it, am I going to put in my t-chart? 0, 1, and 3. Put in 0, I get 0 plus, this ultimately becomes 1 plus, this ultimately becomes 3, 4. 0, 4. Really simple. Put in 1, I get 1 plus, this becomes 0 plus, this ultimately becomes positive 2, 3. 1, 3. Put in 3, this becomes 3 plus 2 plus 0, I get 5. Okay. Now, do you understand? Nothing really particularly interesting happens between 1 and 3. It's going to be linear. I'm combining x's. It's just going to be something x. I could figure out what the equation was if I wanted to by putting in, like, make one of these an opposite of. It's just going to be linear in here. It's just going to be linear in here. All right, follow. As I said, if x is bigger than 3, that absolute value doesn't matter. If x is bigger than 3, then this is just x plus 1 plus x minus 3, isn't it? So it's really just 3x minus, oh, this is minus 1, sorry, minus 1, 3x minus 4. So I could graph 3x minus 4, but I could also do this. Let's just put in 4. Let's see what happens. If I put in 4, I get 4 plus 3 plus 1, 8. So put in 4, get out 1, 2, 3, 4, 5, 6, 7, 8. Notice how that's 3 steps up from there? Slope 3. And I bet if I went down 3 over 1, down 3 over 1, down 3 over 1, I'd end up at negative 4. But we're a line here. But it's probably just as easy. I could do the same thing to the left. I'm just going to put in negative 1 and see where we go. Put in negative 1, I get a 1. I get negative 2, but absolute value 2. I get negative 4, but absolute value 4. I get 7. So negative 1 gets me up to 4, 5, 6, 7. And it's going to be linear. Any questions on why we know it has to be linear at that point? Did we cover that? Not certain it's linear? Because each of these x's is either, when it comes out, because of the absolute value, it's either going to be x or the opposite of x. So I'm either going to get 3 positive x's, or 2 positive x's and 1 negative x, which just gives me an x, or 3 negative x's or 2 negative x's. But when I combine them, it's just going to be something times x plus or minus something. It's going to be linear everywhere other than we make some turns along the way. Probably the only thing interesting here to discuss is range. Range would be from negative infinity up to 3. It doesn't exist until it gets to 3. Parenthesis or bracket, 3. Bracket up to infinity, right? Okay. I think this is going to be pretty easy for you. A f of g of x. F of g of x, given f, given g, is the same as f of x squared minus 3. This is pretty simple. You've been doing this for a while. F is a factory that takes things and adds 5 to them. It doesn't add 5 to each of these. It adds 5 to that thing. So that is x squared minus 3, add 5. It takes that thing, puts it right here for x squared plus 2. Simple. B. G of f of x. You can beat me done. Is g of x plus 5. G is a factory that squares things and then subtracts 3. It's not x squared minus 3 plus 5. It's excuse me, squares the thing. So x plus 5, square it, minus 3. FOIL, x squared, I get plus 5x's, plus 5x's, plus 10x's. I get a 25 minus 3 plus 22. Excuse me. Okay, C. F of g of 0. I want you just to take a second, figure that one out in your head. Hands when you got it figured out. Okay, how about this? Raise hands if you did this. You put 0 in G and got negative 3, put negative 3 here and got 2. Raise your hand if that was the process you went through. Okay, how about this? I've already built f of g of x. So f of g of 0, I've got a factory, is 0 squared plus 2. Now, I'm not saying that's better, but I would say it's probably better. Let's say we had to find f of g of 0 and f of g of 3 and f of g of negative 6 and f of g of 100 of these things. A little quicker route, isn't it? And it could be worse. So let's handle D maybe the way that the author hoped maybe we would. G of f of 0, rather than put 0 into f and the result into g, let's just go to the g factory. And we get 0 squared plus 10 times 0, 0, 22. Again, such easy functions. There's not a huge time savings there, but there certainly could be. E, I have not built g of g, and I wouldn't build g of g of x. I hope that was showing. I wouldn't build g of x for just one. But if I had a whole bunch of them, I might build g of x. I'd put 2 in g, and I get 2 in g, 2 squared 4, minus 3, 1, and then run 1 through g again. 1 squared minus 3, negative 2. And f of x, well, that's f of x plus 5, and f is a factory that puts things, my thing just happens to be x plus 5, right here, and adds 5. Okay. All right. So this assignment is just an extension of the first part of 1-2. You can ignore the 19 through 21 evens. I expect we probably have questions coming on 55 through 56. I think the rest is a little bit more manageable. Definitely quizzable tomorrow with possibly some discussion on 55, 56. If you're having trouble on others, you may want to get those questions answered prior to that. Okay.